Okay. All right. Well, hello, everyone. Thank you for joining the June NBS National Pilot webinar. NBSTRN organizes these calls to discuss emerging findings and practices related to conditions recently added to nationwide screening. Today, I have the pleasure of introducing Dr. Silvia Tortorelli as today's presenter. Dr. Tortorelli has worked to improve newborn screening technology for use in detecting lysosomal storage disorders over the past several years, and has also played an important role in the development of CLIR tools. Dr. Tortorelli currently specializes in child neurology and medical genetics at the Mayo Clinic in Rochester, Minnesota, and is a consultant in the Biochemical Genetics Laboratory. Her most recent work and the topic of her presentation today is the development of a CLIR post-analytical tool for improved screening of Pompe and MPS I. If anyone has any questions throughout the presentation, please hold on to them or put them in the chat window and I will relay them at the end. And so thank you for joining us today, Dr. Tortorelli, and I will let you take over.
Okay, thank you everybody for being here today, and I hope I don't have too many technical difficulties with Zoom. It's my first time presenting like this, so bear with me. So this is actually the work, it's not just my work, but the work of all my colleagues, consultants, and genetic counselor that help with the development and also to relate the outcome of these cases, and so get better understanding of the value of the second-tier test for MPS I and Pompe disease, and this is our older name. So I decided to start with this, showing this poster presented at last year at the ACMG by Perkin-Elmer group, where they show their experience with second-tier tests done by sequences of the IDUA and GAA genes for 5 states. And this is, I believe they follow up more than 180 low IDUA specimen, 100 GAA and 100 GAA. And these are the results. And as you can see, for the MPS I, only 2% of the cases had 2 pathogenic mutations, while for the GAA low results, 25% had pathogenic or likely pathogenic mutation, 2 of them. There's like for both of them, but especially for MPS I, a big majority that they had pseudodeficiency allele. And then for both of them, 21%, they have either 2 VUS or 1 VUS and 1 pathogenic mutation. And this is basically means that we don't really know the clinical meaning of these results. Their conclusion that the sequence is an economic and efficient approach to improve clinical outcome. And I don't know if we can completely agree with that. But for MPS I, the choice of a second-tier test for newborn screening was, I think, pretty easy. Measurement of glucosaminoglycans in urine has been the diagnostic test for forever. And so when we started to look for a second-tier test that could be translated in dry blood spot, there were several options in the literature, and especially this is, we started doing screening for MPS I around 2016, 2017. So we really look at the previous work here of the Japanese and then the Dutch people with enzymatic digestion of GAGs in dry blood spot. Later on, there's also more type of method in the literature. They're looking at no-reducing but I don't have any experience with this test. So just around the time that we were starting to screen for Kentucky for MPS I, we actually heard this talk in one of the international meetings where they showed the results of measuring heparan and dermatal sulfate in dry blood spot, and they show how they were able to very well distinguished newborn screening card of cases with MPS I. There were really elevation of both the markers. And also, of course, it was just one case, but carrier seems to be normal. And down here, patient 11 is an attenuated form, and also in this case, they were able to have abnormal results. So, and this fact and the fact that it was a pretty easy method to add to our laboratory, we decided to go with this method. And just in January, we published our first 3 years of experience as a second-tier test. These are the number of specimen and babies tested. These actually do not include the Kentucky babies. These are all specimens that came to us either from state lab that they sent the original newborn screening card, or as a follow-up of a normal newborn screening of in other states. So we tested more than 1,200 specimens. They were reported negative more than 1,000, so a really big number excludes like as a false positive. This is like being divided in two groups. The first group, that is the majority, have dermatan and heparan sulfate below the 99th percentile of the reference ranges, while 76, the second group, has either dermatan or heparan sulfate above the 99th percentile, but still they were called negative. Of this of these two groups, we only had 34 IDUA genotype. For the positive group, we reported 23 positive. We have 22 IDUA genotyping. One was not genotyped because it was repeated and it turned out to be normal. So looking at the genotype outcome for these three groups, we have cases with wild-type genotype, only 2 in the group 1, so the one with absolutely normal GAGs. Number of cases is deficiency allele. There are, of course, a big number in group 1 and group 2, only 3 in group 3 with abnormal GAGs. There were 37 heterozygote in group 1 and 3 in group 3. And cases with 2 variants, at least 1 VUS, 8 in group 1, 3 in group 2, and 4 in group 3. And cases with 2 pathogenic variants, they were only found in group 3, and there were like at least more than 50% of the cases. These are these figures of the paper show the markers, the heparan versus dermatan distribution versus dermatan sulfate in the group 3. So in the group that it was called positive. And as you can appreciate, there's basically 2 different populations in this group. Looking at the first group with subgroup with very high level of dermatan and heparan sulfate, you see there's the majority that have 2 pathogenic mutation or likely pathogenic mutation, and only 2 they have pathogenic mutation and a VUS. And I think we can agree that this VUS could be reclassified. This VUS could be reclassified as a pathogenic, because really the biomarkers, they behave just like the other pathogenic cases. The second subgroup, the one with the mild elevation of GAGs, it tells a different story. There's only one with that is clinically affected, and then we have several with just pseudodeficiency allele, either homozygous or just one, 2 more heterozygote, and then 2 cases where we have like a pathogenic mutation and a VUS. And in this case, the VUS could be either reclassified, probably at least this one right here reclassified as a benign because it's really behave like pseudodeficiency or heterozygote. When we use CLIR for release our results, and when we have like a case that is as a score for one of the a disease, in this case MPS I, we usually use the dual scatter plot to help us to interpret if the case is actually a true positive or a false positive cases. And this is how it looks in the MPS I when we use the first tier test. So the 6 lysosomal enzyme that we measure plus the lyso-PC for screening for the ALD. And you can tell that is kind of a difference between the two groups, but they're really close. With adding the second tier test, so the dermatan and heparan to the mix, you can see how the two groups, they really separate well. And so I think it's really important to do the second tier test for the MPS I. And the more we have, the more we will be able to tell also this mild elevation of GAGs are clinically significant harm. I know there's one of the big issue for MPS I is can we screen for the attenuated form? We also know that the majority of MPS I are actually severe form, but again, there's some of the attenuated form, and the question is, can be picked up by newborn screening? I believe we can. This is one of the slides that Professor Gabb sent me to show you, and I think is one. This is done by one of the non-reducing end method, and it can clearly pick up 2 of the attenuated newborn screening blood spot that he received. I also have, of course, it's just one, and it's not in the paper because we had this, we tested this baby after we published the paper. But in this case, you can tell that it's clearly elevated, and this is a newborn, and this is his genotype with one of the severe pathogenic variant, but this has been described at least in 2 papers as a attenuated form, and also another argument pro the fact that this baby is going to have an attenuated form is that he has a sibling with the same genotype, and now she's 6 or 7 years old, and she's mostly normal, just showing a little bit of speech delay maybe, and a little bit of hepatomegaly with, again, same genotype and abnormal urine gags. These are all the different variants that we observe in our patient cohort, and it's just show again how this is the most common pathogenic variant, and is seen in a lot of our patients. This is the second most common severe variant, and then also there's a lot of the one in green are all pseudodeficiency allele, and again, there's really present in a high percentage in the population. And then also another point to make, there's a lot of new variants with really uncertain significance that we don't know if they're either benign or pathogenic. And so I think having a biomarker, positive biomarker, actually helps a lot following up this patient. Switching to Pompe disease, again, this is like a collection of papers in the last years looking at possible biomarkers for Pompe disease. Like GAGs for MPS I, the glucose tetrasaccharide were the first thing that came in mind to do a second-tier test, to offer a second-tier test for Pompe disease. But beside the fact there were no paper looking at the marker on blood spot, there are also this paper right here that they say how really not sensitive was, because even in infantile form, the glucotetrasaccharide excretion in urine can be normal. Then here in the middle of the slide, there's like the Taiwan experience that were one of the first to do a pilot study on Pompe disease. They had a lot of false positive because they have high number of pseudodeficiency allele, and so they tried to come up with a second-tier test to help to reduce the number of second-tier tests, and actually they were able to reduce it, but not of a lot, adding the neutral alpha glucosidase activity as a control enzyme. And then just this past few months, there are the first these two papers, the Georgia and the California experience from newborn screening for Pompe, where Georgia used as a second-tier test the analysis, as a first-tier test the analysis of GAA and IDUA, and then when one is positive, they do as a second-tier test the analysis of the 6 lysosomal enzyme, and using CLIR tool for the resolution of the case. While the California experience use as a second-tier test molecular sequencing, and again they found really what a lot of people found, a really high number of late onset cases and quite a high number of VUS. So looking for a second-tier biochemical second-tier test that would be easily introduced in the laboratory routine, we came across to this paper published 7 years ago, that it was about metabolic abnormalities in 30 or so cases with adult onset Pompe disease. And the paper show how there was like a impairment of the methylation and in this patient, and actually this impairment was showing with plasma abnormality, and particularly what caught our attention, the fact that the creatinine was going down and the creatine actually was going up. And this caught our attention because we measure creatine and creatinine in our newborn screening for beta oxidation, organic acid, and amino acidopathies. So it's part of the amino acid and acyl-carnitine profile in blood spot. So we thought that it would be a pretty easy thing to check if Pompe case would have like an abnormal, especially ratio, creatine to creatinine, and to see if it could help us to distinguish false positive to true positive. And that's brought to the publication of this paper, where we validated the creatine to creatinine over GAA as a second-tier test. These are the percentile of reference ranges, not adjusted for any covariate here. And as you can see here in this figure, the creatine-creatinine ratio is actually not really different from the reference ranges and amongst Pompe and false positive. And here also you can see how the GA activity by itself, it cannot always distinguish between false positive and Pompe disease. But when you had the creatine-creatinine ratio over the GA, you actually have a better differentiation between Pompe disease cases and false positive cases. To again validate that, New York State sent us 39 blind samples, and we had a pretty good concordance with them. The one in bold are the one that were like actually not discordant, and the first 3 that we were called false positive, they're actually homozygote for these variants that was at the beginning published as a pathogenic variant, but now is well recognized as a benign. So I think that is like the false positive is actually correct. And then this three down here where we call it as Pompe, but actually one is false positive and the other two again with the variants of unknown significance. So we thought that it was a fairly good outcome, and we decided to offer this as a second-tier test. And so these are almost 3 years that we offered this test. So this is from July 2017 and last month. We tested almost 1,000 babies. Again, these are all babies, all blood spots that come from either state lab as a second-tier test of abnormal to newborn screening or as a follow-up of an abnormal newborn screening. And we call negative almost 900 cases. We only have 15 J genotyping, and so far we know of 2 false negative, and this is the genotype of the 2 false negative. Again, with the late onset pathogenic variant. This second case right here is actually was called negative, but was done at a older date. It wasn't a newborn screening. When we tested the newborn screening card, it was actually positive. And then we released as a positive several. Of 17, we don't have genotyping information. 2 of them we know the repeat was negative. Then in the other, we have 27. There are false positive. 33 were at least one, if not both, the variants are VUS, and 64 were the 2 alleles are carrying pathogenic or likely pathogenic variants. And we have 124 J genotype. The CLIR in the case of Pompe is really a critical part of the second-tier test, and especially the single condition tool and the dual scatter plot. The single condition tool is made of 4 components, and the first one is the case detail section, when you have the covariates of the baby, the informative marker that can be low or high, and the differentiator markers. The differentiator markers are not informative per se, but they are important either to distinguish one condition from another, or because are part of one of the ratio equation that are in the making up the score of this single condition tool. The second session is the plot by condition chart, and this is like a nice visual tool where you can see how your case compare with the other cases. So the green box are the reference ranges, while the blue boxes are the disease ranges. And your case, and I'm going to show you actual single condition tool later, is going to be like a diamond, a black diamond. And again, it can tell you where is compare with the other Pompe cases. Then we have a score report section right here in the middle, where you're going to see the score for your case, how is the percentile rank of all the Pompe scores, how many cases are in the disease as a true positive. Then you have the score interpretation guideline, where they say what the level of the score in which category is fall, like non-informative or informative. And then right here is the score range. And again, it's a visual way to see the case score. And again, a black diamond is your patient and how it compare to the other cases. And then the fourth component is the score calculation tab. That is this one right here, where again you see your markers, low or high, and the differentiator with the reference range, the first percentile for the low informative marker or 99 percentile for the high informative marker. For the differentiator, you can see both first and 99 percentile. Then for the low and high marker, you can also see the overlap of the reference range with the disease range. And you can see some of them, there's no overlap at all. On the right, you see N stand for number of cases that have this marker. VUT is the value under test, so the value of your cases. And the AVUT is the adjusted values, and it can be adjusted either for covariate, like age, gestational age, birth weight, sex, but even for location. And here you have the initial score. The initial score is what actually comes from this table in the middle, so the informative disease range score in percentile. And basically, again, show you the percentile for the low and high marker for the disease ranges, and where your case it ends up to be, and give you a score depending where. Oh, sorry. Okay. Yes. Sorry. Where the and give you the score that then is going to be the sum is going to be here. And this is finally is the correct score that is multiplied. This is the initial score for each marker, multiplied for a correction factor, which is based on the degree overlap between reference and disease ranges. So you can follow again the score, and here you don't see the initial on the differentiator, initial and correct score, because differentiator do not contribute directly to the score. So to make like an example of how we use that, these are two cases that I found that are pretty similar to them, between them, as a age, birth weight, gestational age, they even have the same sex, and also really similar as a GAA level and creatine over GAA ratio. But in one, and also if you look here, the plot by condition, they also look fairly similar. But one was released as negative and one was released as positive. And that is why. So if you look at the score calculation tab for both, the one on top is the negative, the one on the bottom is the positive. Again, you can see that the score for the ratio is exactly the same for both of them, while you start to see differences when you're looking at the low informative score, GAA and GAA over single myelin. And then again, other ratio that really helps you to distinguish true false positive. And this is the score, and this is the score that you're going to see on the single condition tool, the rank of all Pompe score, count of the score, and again here, how your case, the black diamond, compare to the other Pompe cases. If we use the DUA scatter plot in these two cases, you can see the positive, it goes with all the other Pompe, and the one that was called negative actually goes in this area that is called indeterminate, because you have both false positive and Pompe cases that they fall on the same area. There's actually a really nice tool for the DUA scatter plot that is like help you to look at this indeterminate areas. It's called the zoom, and you can see how the one that was called negative is actually goes with the negative cases. And this is the genotype resolution of both cases. So the negative is actually a heterozygote for the late onset mutation, and the positive is a compound heterozygote for the late onset and another variant. These are just 2 slides to show you like our experience is really kind of similar to the other. We have actually a fairly good number of pathogenic variants, but if you look at this, there's like also a generous number of VUSs or variants with conflicting interpretation, and also some other unknowns. So a lot of cases where actually molecular sequence is not really helpful to distinguish a true from a false positive. And then looking at the characteristic of the pathogenic variant, again, there's like a vast majority that carry in the late onset variants, and that is the second most common. And then you can see there's a lot of 1 or 2 or really small number of cases. So making the point that you're going to see a lot of different variants, private variants in these babies. With this, I'm done with my talk. I think there are few take-home points. I believe that the second-tier test, the biochemical second-tier test, improves specificities versus sequencing, especially, I can tell, by MPS I, probably also for Pompe, but for sure for MPS I. There's a much better turnaround time. The average turnaround time for a second-tier biochemical test is 2 days. And also making the point that post-analytical interpretation is important, is really important, and especially the second-tier test for Pompe depends on it. And also it's really important to know the outcome of these cases because they help us to refine our post-analytical tool. And with that, I'm ready for questions, and thank you for your attention.
Thank you, Dr. Tortorelli. Just trying to think about the best way to handle questions. If you guys would like to raise your hand on the Zoom bar, I can call people out and we'll just go one at a time. Or if you have any questions, you can put them in the chat as well. Are there any questions out there? You can unmute yourself and speak up too, since we're not getting clogged up. Okay, I guess I see that there's one from Natalie. And her question is, would you refer SC positive for MPS I daily or weekly?
Oh, as a second-tier test, it's really rare. Most of the one that we release every day are normal. Okay, I shouldn't say every day. I think we do the test twice a week, and they're normal. Most of them are normal.
Everyone is currently unmuted right now and can join in the discussion.
Jennifer Taylor, yeah, go ahead with your question.
Okay, well, I can relay Jennifer's question. Her question is, how long is your turnaround time for both second tier tests?
Yes, it's, as I show in the last slide, is around 2 days.
Okay. And we have another question here from Annette, and she asks, which state NBS labs are using the CLIR tool to help reports?
That I don't know.
I guess she modified her question here, and she asks, which states NBS labs are using the CLIR to help reports if blood and urine gags are normal by age 1? By age 1 year, could it still be attenuated MPS I?
No, sorry, I don't understand the question. Again, as an attenuator, I really have one case experience, which is not enough. But that case, that baby had a fairly high, not as high as the one with the severe form, but it was fairly high level of both dermatan and heparan. It wasn't really on the second subgroup that I show where there's a lot of, where there's like carrier or pseudodeficiency allele cases. It was, again, standing up. So again, it's just one case. So I don't know if all the attenuated form behave like that, but I think is encouraging.
Okay. We have another question from Tracy. Would you recommend genotyping for a sample with either DS or HS elevated, but not both?
No. I think they're normal.
Huh?
Okay. Are there any further questions out there? I don't see any others coming in. Oh, here we go. Question from Devinder. Any experience with GAA IDUA ratio?
Yes, probably. I mean, I'm pretty sure it's in the single condition tool, but I would have to check. But we're also able to see when a sample is like artifactual low, because usually you have more than one enzyme on the low side. So that's also the strand to have more than one lysosomal enzyme to be tested, together.
Piero, do you want to talk a little bit more about that ratio?
Yeah, again, I don't have I don't have the data right, but again, it's like with any other lysosomal, I mean, with other enzyme ratio, it helps you to distinguish when one is normal and the other abnormal, to separate when is true low enzyme or is like artifactual because of the sample handling.
Great. I think everybody, has been commenting, and we've certainly heard it over the past months, how much this tool decreases false positives. So I know we've gotten a few chats in the window about thanking the Mayo team for providing this tool.
Yeah, it's probably the Georgia paper talk a little bit more about that because the first year test is just IDUA and GA. But then really they're using as a second tier test more enzyme to also help to distinguish the false positive to the true positive. For us, we also have the lyso-PC, which actually the ratio with the lyso-PC it seems to be informative, especially if I remember correctly in Pompe.
It's Bill Wilcox. The hardest part for us in Georgia to get this to be used prior to reporting is really the computer pipeline to pump from the results into CLIR and then into the reporting. That's what's taking all the time. So when we did the Pompe and MPS I screening, we were doing that more or less manually, pumping the results through into CLIR. So we weren't doing it automatically. That was a pilot study funded by the NIH. We're Tricia Hall's contracted now with the newborn screening lab and is implementing CLIR tools pre-reporting, which will be fantastic.
It is hot. After we check on Nellie, okay? We'll get one. Nellie, did we finish our lunch?
Yes, I see the point. For us, it's pretty easy. We have a CSV file for every task list that we have, and we can run it and have it basically. So I understand that doing one by one manually is a lot of work.
Yeah, you don't have the you know, you've got great IT resources, which not every state has.
It looks like Sean has a question. What's the cost of the second tier biochemical test approximately?
That I don't know. Dawn, can you help us?
I think it depends on if the submitter is a client or not, and depending on the contracted price. I know that newborn screening labs who are using these as second tier tests have a much lower contracted price than what's listed, but it really varies. It can be as low as less than $100 or anywhere, up to $200, but it really, there's not a set across the board price. It's all contracted pricing. And then you can contact us and we can help you, figure that out, like offline if you're interested.
Joan, I see your note about Michigan has been using this for a few years following the DMF babies first tier test. Do you have any idea of the percentage of lowering of the false positives, or is it, are you able to quantify that at all?
Hi, can you guys hear me?
Yes.
Hi. So I got a few updates from the lab, and I know Mary Cedarlin and Sean are on also, but the notes that I made before the call is that we started our digital microfluidics screening for Pompe and MPS I in August 2017, and we started second tier for Pompe in August 2018. Okay, so overall, we've had 166 strong positive results for Pompe disease since we started. Since starting second tier, there have been 18 positives, strong positive results.
Wow.
And of those, 17 are known to have been affected, 1 with classic infantile, 2 with non-classic infantile, and 9 with late onset, 5 with, like, they're thought to be pathogenic, like likely pathogenic, but with unknown, unpredictable onset. And so they're being monitored.
Wow, that's great data. Gretchen asks, what about the estimated cost for states that want to perform the biochemical testing on site?
That also, I don't have an answer right now, but if you want to send me an email, I can try to find out.
This is Piero Rinaldo. Can you hear me?
Yeah.
Yes, dear.
If they do all the testing on site, they don't have to pay anything to use CLIR as long as they submit data. So they can be just a regular user, enter their data, and calculate the score on their own.
Yeah, I thought that they wanted to know how much it costs to implement this test.
Well,
That's
it
why
says perform.
Yeah. Okay. Yeah. Not. Yeah. You don't have to pay us anything.
So maybe Gretchen can elaborate on that question and tell us what exactly is about. What's the cost of setting it up, or the cost for having interpretation of the results using CLIR? Because I'm not sure. It can be interpreted both ways.
I guess both. The cost of implementation and then the cost to actively perform it routinely.
Well, the cost implementation is really depends if you are starting from scratch, and if you have instrument capacity, if you have personnel, and so I don't think neither Silvia or I can tell you on top of our head. But that's certainly one thing. We have helped quite a lot of programs, with not just these two, but many other second-tier tests. If they're seriously interested, we can certainly help them to provide at least the SOPs and even some sample exchanges to set it up.
Thank you.
Piero, who would they contact if they were interested in getting that started?
I would go to Silvia or myself, or on Dawn. So anything. We work very closely as the lab directors and genetic counselors. So basically, any of us can be a point of entry. Whenever an inquiry comes in, the first thing we do, we just bring the others into the conversation. So any of us is a good way to approach us.
So Dr. Rinaldo, next question might be for you. This is from Dean Sir. Can you share a sense of what the national and global participation in CLIR is?
Well, we actually have built-in CLIR tools. I haven't looked at 2020 data. I can tell you that in 2019, CLIR tools were used 321 million times. So 600,000 times a day, more or less. Certainly the participation is predominantly international. I would say we have far more users outside of the US than in the US.
Thank you. And Kevin's just showing on the screen, this is a recent publication from Dr. Rinaldo's group on the comparative effectiveness of newborn screening for 4 LSDs. And MBSTRN was partly a supporter of this, but the paper just came out and it's got a lot of really great data in it. So if you need any references or if you want to look through that, I think it's freely available. If you just do a Google search for the title and the first author.
actually, Amy, if you people go to the login page of CLIR, we have a link. This is part of a special issue of International Journal of Newborn Screening. We are going to have probably between 12 and 17 papers about different aspects of using CLIR for newborn screening applications. The Georgia pilot study is there, among others. There is a paper about multi-year experience both in Sweden and Norway. And there is a lot of good stuff there. But again, if you go to a login, which is clir.mayo.edu, on the left side, maybe you can even do it as we speak, but you can show it. It's there. You click it, and all the papers accepted are listed there.
Do you want to try that, Kevin?
Sure.
Yeah, you see down there, publications, CLIR application for newborn screening.
Wow. That's
And
awesome.
if you scroll down, there is a little bit of introductory text, but if you scroll down, here, so far we have 8 papers that have been finalized, submitted, reviewed, and accepted. So there is a second tier test for propionate, methionine, and cobalamin, so the homocysteine methylmalonic methylcitric. There is a paper by Georgia. There is a very cool paper from a group that does machine learning using data from California, the second tier test, and so on. So, and if you go even lower, you might find the other papers.
Looks like this is
Here.
I can go.
So there are quite a few others coming, but the nice feature is that when they are uploaded here, the link on the login page will take you there to the latest version. Yeah, that's a Sweden paper, and the Norway paper I think is still not there yet, but it would be there soon.
That's great. Okay, well, I think our time is up here, and so I'd like to thank Silvia and Piero and Don and the whole Mayo team for putting this all together and presenting and really getting the information out there. And if anyone else has any other speakers or topics that they would like to put forward, you can reach out to me. I think everyone has my email from the invite or from the APHL listserv. Because we're always looking for new topics to talk about. So we didn't get to the state reports, so I guess hold on to your reports for July during our next meeting. And with that, thank you all for attending, and I hope you all have a great day.